Hey, good morning, and welcome to another episode of Between Two Nerds. I'm Jeff Doyle, and with me is my friend and associate Jeff Tansura. Good morning, Jeff.
Good morning, Jeff. Great to see you.
Good to see you too. So, before we get started, our administrators, kind of behind the scenes here, asked me to remind everybody that's here. If you like what we're doing, if you're enjoying it, please be sure to hit like on YouTube and to follow us on the channel. The other little piece of housekeeping that we've got here, having to look at my notes to make sure I have it right. We'll be back, as you know, we've been doing these shows every other week. We'll be back on September 17th, but then we'll be taking a break on October 1st, which would be the session after the next one. We'll all be participating in Network Field Day, and so won't be here. But just wanted to let you know that, and we'll certainly remind you again in our next session. So this is a continuing discussion of EVPN route types. And in the very beginning, we introduced, there's route types 1, 2, 3, 4, and 5. There's also a few route types that are used just for multicast. And we've talked about that the route types that are really essential are types 2, 3, and 5. And we've gone over 2 and 3. And what we're going to discuss today is route type 5. And kind of going into the back of that, if you've listened to what we've talked about so far, we've talked a lot about how the route types are used to be able to take traffic from a VLAN into a VNI over to other participants on the same VLAN on different switches. Well, what happens when you want to route from one VLAN to another VLAN? You could just attach a router, and people do this. You could attach a router to a spine switch, to a leaf switch, and sort of have the one-armed router in there. Just picturing that, it should be obvious to you that that's really inefficient at least for east-west traffic, to have to send everything to an attached border router and then send it back into the network on a different VNI. It would certainly be better to be able to do all that inter-VLAN routing right in your switch architecture, and that's where we get to type 5 route types. Jeff, you want to talk a little bit
I'll
about that?
probably take it from there. And so the goal of today's podcast is to finish discussion on basic route types. So route type 2, 3, and 5, before we go into wonderful land of multi-homing and potentially multicast. So we will do a short recap on all route types we've covered so far, and then discuss some basic deployments mode with the simple route types.
Cool.
Okay, so here we go. As we said, we've covered during last 2 months the basic EVPN route type. Route type 2, route type 3, and route type 5. So route type 2 advertises MAC or MAC and IP address, where MAC is mandatory field, IP address is optional. Configuration-wise, you would always see configuration of an VNI, which is the only identifier in data plane. So when you look up VXLAN packet, VNI is uniquely identifying this particular. It stands for virtual network identifier. So this is what your ASIC, your data plane, looks up when packet comes in. Usually you would have an RD or route distinguisher associated with what we call layer 2 VNI, as well as route target used to import the route. So what you see here is configuration on Junos on one side and Arista EOS on another side. To make things more complex, there are actually 3 different types of type 2s. They are not spelled out this way in RFC, but they are actually 3 different types. They look differently. We've got MAC-only route. So when new MAC address shows up in data plane, everybody in BGP will get an update from the switch that owns the MAC address. So you will see this specific route in this way. It's type 2 route with MAC address in it, nothing else. There's MAC and IP. So we use ARP to resolve, right? So when someone ARP, you know not only MAC address, but also IP address. In this case, you could distribute both MAC and IP in type 2. So remember, IP address is optional. If you don't know it, if you're in layer 2 only environment and you don't do proxy ARP, you won't see IP addresses.
Yeah. So it's fair to say that this is kind of an internal replacement for ARP.
Yeah, it's distribution of ARP. I mean, it's very important. It's very important addition to EVPN to reduce amount of broadcast traffic over the LAN, right? Because imagine you've just ARP, you've learned MAC and IP, but it's only you who knows that. However, by using route type 2 with both MAC and IP, now you let everybody know, look, this is the MAC address, this is the IP address bound to it. If you need it, don't ARP anymore. It's there. So everybody will know, which reduces amount of replications. If we look at vendors implementation, there are differences. And this is where the third difference is coming in. There's MAC plus IP that has both L2 VNI and L3 VNI. Let me use pen to show you. So what you see here is Cumulus. You see it's route type 2. It has MAC address and IP address. It also has 2 VNIs, layer 3 and layer 2. It has 2 route targets, layer 2 and layer 3. So when you get this update, you can install MAC address into your bridging part. You can install IP address into your VRF. On another side, you might have, actually, you do have implementation that don't do double label type 2s. They do single label. So even when you receive MAC address and IP address, there's only one VNI, there's only one route target. So information to be used is really MAC address. You would also see route type 5 that we are going to cover now. That is part of this advertisement. You'll see exactly the same route. So it's going to be 50, 50, 55 that has now layer 3 VNI and route target associated with it. So there are 2 different implementations. Both have pros and cons. Route type 3 is used to build a bridge. So EVPN bridge domain or EVI is nothing else than a bridge. It behaves like a bridge. So you need to be able to flood BAM traffic, BAM standing for broadcast, unknown, unicast, and multicast. So route type 3 is used specifically for that purpose. When you have configured your EVI, a switch will advertise route type 3 as per EVI and build membership lists that results in flooding list in hardware. So anytime there's broadcast or multicast or unknown unicast traffic to be sent out, it's going to be sent towards the flooding list. In VXLAN fabrics, we usually use Ingress replication, meaning the Ingress, the source of the packet, is going to replicate 1 packet per receiver. In MPLS environments, you could also use point-to-multipoint RCPT, MLDP. In data center environment, usually it's PIM and multicast if you use network replication. So as we said, there's going to be replication or bridge domain per VNI. So anytime you configure new VNI or new L2VRF or whatever terminology to use, you will see replication across.
And that's a pretty good slide for showing what I was talking about in the beginning. Everything we've covered so far. You can see VNI 1001, 20001, and 30001, and so there's obvious connectivity from the attached VLANs for those VNIs, but there's no way so far of communicating between those VNIs.
So let's take a look. Imagine we want to communicate from this VLAN to that VLAN, right? So they're on the same VLAN, they're on the same domain, and since it's layer 2, we should be able to switch traffic between them, right? But when I'm sending first packet, actually I don't know where to send it, right? So I'll broadcast it, and in order to broadcast, I need to know everybody else who participates in this service, right? So in this case, it's going to be this guy and that guy. So what it means, when you have configured this instance here and there, both of them will advertise type 3 route for VNI 10,001. So when I'm sending traffic that is broadcast on this VNI, since I have fluid list that has these two switches, I'll send one copy to this switch and one copy to that switch. So the VM that's connected here is going to reply, and this is how we learn. And by the way, when this guy is replying, I will see the reply, I'll learn it in data plane, and then I'll advertise it to everybody else in BGP. So next time when I need to send traffic to this VM from here, it's already in my BGP table and instantiated in bridge as an MAC entry. So it reduces amount of flooding, and it makes distribution immediately aware of any new MAC address that shows up on the fabric. So this is how type 3 is formed. It borrows RD from L2 VNI associated it, and the originating router IP address is obviously the VTAP. So this is how it looks like. We'll move further. So route type 5.
Hey, just to interrupt, we did get one question. It's kind of a different kind of question here. From one viewer, says, inquiry minds want to know, what is your favorite route type?
I'm a routing guy, so yes.
Yeah, it's funny. I'm the same way. It's, I've been spouting off, and it's kind of a good lead-in question because I'm a routing guy also, and so very definitely my question on all of this so far has been, well, how do we communicate from one VLAN to another VLAN? You have your storage network on one VLAN. How do other users get to that storage network? And by golly, here's where we are.
Yeah, so since we had route type 5, there's some history behind, right? So route type 5 is not covered by base EVPN RFC. It came up later. So remember, EVPN was built as control plane for VXLAN, and VXLAN was built to extend layer 2. So practically, type 2 gives the ability to distribute IP addresses, but those are only host route because there's one-to-one mapping between MAC to IP address. And back then, routing was kind of not thought of because we were extending layer 2.
Yeah.
And very soon it became obvious that EVPN is going to be L3 VPN and data center. There's no reason to run two protocols. So you need to be able to advertise IP address or IP prefix separately from MAC address, which is type 2 route, right? You cannot advertise IP without MAC. MAC is mandatory. You need to be able to connect to external world and get your static route or default route into your fabric so you know how to exit it, right? So this is how type 5 route came into existence. Later, covered by separate document called actually IP prefix route, VPN. So has different history, came up later, and for very specific reasons. So we are going to take a look at route type 5 and how it's configured, how it looks like on the switches. So it has its separate route distinguisher. ESI is used for somewhat complex reason. Just assume for this case it's 0. And we are going to be talking about internet interfaceless route type 5, which is the one mostly used across vendors. So this is the prefix part. As you could see, it has no limitations with regard to its subnet part. So it could be anything from /32 up to /0 in default route and v4 vault, and same for IPv6. So what we also see is it has its own RT. So import of type 5 is completely decoupled from import of type 2s. In order to be able to switch towards the destination, we still need to know MAC address. Remember, EVPN is inherently layer 2 technology. So it could be done in 2 ways. You could use type 2 routes that have router's MAC address to do recursive resolution, or you could install this piece of information as part of type 2 5. And this is where you see router's MAC address encoded. And obviously, we always need to know how to encode outgoing traffic. So in tunnel encapsulation extended community, we have type VXLAN for our deployment. So how does it look like? I've got Junos, FRR, and Arista for you. So I didn't include Cisco, probably for next time. So what you could see here is type 5, and
by the way, if you're watching on a mobile device, these sessions are being recorded, where you might be able to later on. If you're having trouble seeing, it's kind of rough to get this essential information all on one slide, but these sessions are recorded where you might be able to bring it up on a larger screen where it's easier to read this information.
Yeah. So if you're not looking into detailed show on Junos, you see only the NLRI itself and ISPass. If you look on FRR, even in shortest view, you get to see significant amount of information. So since I really like how it's presented, so it's route type. This is the route itself. This is the length of the route. So in this case, it's /24. This is VNI associated with the traffic. So when it hits the switch and switch looks up VNI value of the packet, it will know it belongs to this particular L3VRF. Mm-hmm. And as we said in encoding, it has VXLAN in it. So the 8 is VXLAN. Obviously, could be in PLS and PLSN route. Has its own route target and router's MAC address encoded in the community. Looking at Arista, so this is a very important part. This is default route injected by external party. So we use type 5 routes to route outside. So encoding is somewhat different, but you get exactly the same information, your RD. It's actually very cool to see what does it do to your ECMP. So in this particular case, it is used for ECMP. It's also ECMP head, which has to do with which route is the most important one in CB bundle. In very beginning, when we started, we talked about fast convergence. So in the CMP case, there are 2 cases what happens with regards to route withdrawal. So if you're ECMP head, you need to completely calculate. If you are just ECMP contributor, you just do implicit withdrawal. So it's really good to see this information present. Arista, well done. So route target, it's VXLAN. So this is exactly that. It just encoding here shows you the number, encoding here is translated in what it is. And as we said, we always need to know MAC address of the router. So configuration. Guess what? type 5 routes live in a VRF. It's an IP concept. So looking at Juno's instant type of routing instance is VRF. We have got RD, we have got RT. So remember, advertisement of route type 5 is completely decoupled from route type 2, as has its own semantics. So on RD, on RT, and on VNI. This is important. It reduces amount of lookups receive and switch needs to do. Like in MPLS case, when you look up inner label, you know which next hop and which VRF it's associated with, depending on label allocation mode. Same goes for implementations with VXLAN. When you look up VNI, it gives you all the information needed to immediately associate it with VRF and potentially next hop within the VRF. Right? So it reduces amount of operations you need to do on ASIC. Looking at Arista, we have an RD. We have route targets here. So for sake of example, I also included IPv6. So as you could see, I've configured route target import and export to be the same. You can actually decouple them. So you could have different import and export policies for v4 versus v6. And since we need different VNI for layer 3, this is the association of VRF blue with VNI. So configuration per vendor looks quite different.
Yeah.
So
being an old Juniper guy from for years and years, this is a great illustration of why I kind of love Junos. I always like the logical arrangement of a Junos configuration. Yep. I shouldn't say that because we cover everybody.
We cover everybody. So an XOS and FRR to less degree is going to look similar. Why? Because iOS CLI has become standard.
Yeah.
Long time ago, right? So there are two interesting topics, namely asymmetric and symmetric IRBs. Let's discuss the differences. And what you see in today's deployments, it's symmetric IRB only. We'll discuss why it's that. So asymmetric IRB performs bridging and routing on ingress, so source of the packet, and only bridging on egress VTAP. This was really important in early days of VXLAN because of support of VXLAN on ASICs. Doing 2 lookups is obviously more expensive than doing 1 lookup. And this is where asymmetric IRB came in. What it really requires, on the other hand, is to have same VLANs configured everywhere, because you are bridging and routing on ingress. You can only bridge, you cannot route on egress anymore. So the model is, as we said, bridge, route, bridge. This is your ingress. You bridge to the router, and then you only bridge here.
I've been actually for a while trying to think of some decent parallel illustrations between asymmetric and symmetric. The closest I can get, I haven't ever said this to you before, so maybe you disagree with it, but the closest I can get for somebody that's trying to comprehend the difference between asymmetric and symmetric is that for asymmetric, it's kind of like a hub and spoke arrangement. And actually, the more I think about that, maybe I'm already convinced myself that's not quite accurate. But if you look at everything from a hub perspective, that hub has a route to every spoke. I don't know. I don't know if I like that or not.
So this analogy is not exactly correct, but it's very close, and it's a very good analogy, because at the source, you need to know what's in your destination, right? So which creates kind of global dependencies, and it's somewhat inefficient from distributed system perspective. Why do we call it asymmetrical? Because communication is almost always bidirectional. So when you go back, you'll have to do double lookup here and single there. So there's some asymmetry in the way you send traffic, right? The operations on ingress and egress are different, hence the name asymmetrical. Let's go into symmetrical IRB. In symmetrical IRB, both switches perform exactly same operations. They breach route and then route breach. So one more lookup on egress. However, you don't need to have any remote information local switch. You use special instance to route traffic between two different switches. So let's take a look. On ingress, we do bridging and routing. We use special instance to route to egress, and then we do additional lookup to figure out where to bridge it to. Right, so there's definitely one more operation on egress. We are not only bridging, we are also routing, but it creates symmetrical structure. When we go back, we do exactly same operations. We bridge route and route bridge.
This is actually where, in trying to think of analogies, I would think of this as kind of that that backbone, if you want, VRF that you use to route everybody's, kind of like a WAN network or something like that.
So there's this special instance that takes care of routing between switches. And if you look at current ASICs, so either any vendor ASICs or Trident 3, they all do symmetrical IRB without any limitations. On older ASICs, there are some limitations. And again, this is why IRB asymmetrical mode was invented in the first place. So as of today, there's absolutely no reason to do asymmetrical. And if you look at any modern deployment, they all do symmetrical IRB. How are we doing on time, Jeff?
We've got about 3 minutes left. Do you want to save this for next time, or
let's go through it quick and then start with this section. So I wanted to cover the basic deployment modes, actually, what we do. So basic EVPN is bridging, right? So layer 2 only, no layer 3 whatsoever. In order to exit Fabric, you need a default gateway configured on every device. In order to provide resiliency, usually we would have router or firewall connected to this layer 2 segment and using VRRP or HSRP if you're a Cisco club to provide first hop resiliency. So this IP address, that's virtual IP address for VRRP, is your next hop on the hosts. Simple, really mimics how switches work. If you need to do layer 2 over layer 3 and want to keep it simple and resilient, this is the best way. Make sure you understand how VRRP works. It uses multicast. So before you do so, test that your VRRP hellos are get through the switch to this guy, right? Because if they don't, you want to establish VRRP relationship. It's not going to work. So test before you deploy, which is true for every deployment, but specifically here because you might see some funky behaviors depending on vendor. Classical combination of layer 2 and layer 3 covers both bridging and routing. So as long as you are within same VNI and same subnet, you're going to switch. It's a switch, right? If you're in the same bridge domain, you don't route. However, if you need to route between ranges, between VLANs, between subnets, you've got the IRB interface, and common way to deploy it today is to use Anycast. What it really means is that you're advertising same IP MAC address everywhere. Why it's important? Imagine it's a VM and you move. Since you're anycasting your gateway, you don't need to relearn anything. Your MAC to IP binding for your gateway is exactly the same because you advertise it to everywhere. What's also very important is how efficient it is. When you ARP, it's exactly the same here, and the closest point to you is going to answer it. So imagine you've got non-anycast So it's somewhere here. In this case, anytime you are on NIT layer 3, you would go to this guy, right? Very inefficient. In any cast gateway case, you would just hit closest switch to you, the switch you are connected to. And the last deployment mode is really replacing L3 VPN-alike structure with EVPN. So in this case, you're out. So imagine all these guys have their 32s, so there's no common subnet. You might also have some subnet here, but it's different than subnet here. So you use route type 5 to advertise who you are, your IP address, and you use it to route traffic in between. But remember, we cannot switch traffic between different VLANs. So those are 3 common modes of deployment. There's more to that, but I wanted to share how EVPN is usually deployed. So I think this is a good point to stop for today. Do we have any questions?
The only other question that came in, and I apologize for my dog barking. Somebody said, "What routing protocol does your dog prefer?"
RIP, obviously.
RIP. Hey, no, my dog prefers ISIS. I raised him right, even if he doesn't behave in online meetings. So anyway, I think, Jeff, that's been a great run through of Type 5. I think certainly on our next session, we want to go into some more detail on the deployment scenarios. Coming up, we've sort of discussed in the background. We want to talk a little bit about maybe. Well, for one thing, we haven't talked about types 1 and 4 yet, so we want to talk about where those might be used, and then also maybe on multicast, things like Cisco calls it tenant routed multicast. But how do you implement multicast in an EVPN network? Not multicast in terms of handling bum traffic and all that, but multicast routing, PIM networks, I guess you would say. But anyway, we'll do all that in the future. We'll also at some point, we are both Arista guys, and at some point we want to show you did I say Arista? Apstra.
Yes, you did.
Sorry about that. We at some point want to show you how Apstra pulls all this stuff together in a GUI based deployment scenario. But that's for the future. We've still got a lot of basics to get through. But for now, Jeff, thank you very much. And I'd like to remind everybody once again, if you enjoy what we're doing here, please be sure to hit like on YouTube and follow us on our YouTube channel. And with that, we'll see you in 2 weeks.
Jeff, thank you. Thanks everyone for your time and attention. Please let us know. Again, we're always looking forward to your questions, trying to address them as best as we can. We can show you again some live deployments. I always have at least 2 different vendor EVPN fabrics running for you if you have interest in seeing it. Stay safe and see you in 3 weeks. Thanks, everyone. Bye.